I'm Jorge Alio. I'm talking to you from the ESCRS 2023 meeting, which I received the Binkhorst Medal. It's a big honor for me and one of the highlights of my personal career. And the topic that I selected was corneal regeneration. But let me explain to you why. Corneal regeneration is the future of corneal surgery and the future of the treatment of corneal blindness. Corneal blindness is affecting at this moment 45 million minimum of patients worldwide, and every year this number increases 1.5 million because the lack of adequate supply of corneas and donations and the corneal donors are the main problem for corneal graft. Every year in Europe we increase in 40,000 cases the backlog on cases untreated. That means that we have a problem with the supply of the cornea. The problem is how we treat the cornea today. We treat corneal transplantation, corneal transplantation procedures, even that they are successful. We have to not to forget that there are a high rate of anatomical failures. Anatomical failures are said those in which the cornea never becomes totally transparent, and that comes from 28 to 34, even to 50% after 5 and 10 years. And moreover, you have functional failures in which the corneas become transparent, but they are not providing good vision. About 30% of the corneas transplanted with PKP and deep anterior lamellar graft end in less than 0.3 BCVA or 0.4 BCVA, which means that we have a problem with the refraction and binocularity of these patients. If these results were the ones that we have in cataract surgery or refractive surgery, these surgeries couldn't be practiced. So that means that we need something better, and something better should be with no immunogenicity, universal, easy to transport, and with no limitations in terms of availability. And this can be done only with corneal regeneration techniques. In my lecture, I demonstrated that this is feasible now with mesenchymal stem cells from adipose tissue especially. These are the ones that we use, and we can regenerate the corneal epithelium with these cells. We can regenerate corneal stroma associated to bioengineering procedures using at this moment human cornea, but also xenogenic tissue from porcine origin, and finally in the endothelium that today, thanks to the studies that happen in Japan, is possible to offer this type of therapy with the stem cell therapy and with the cells and not with transplant to the patients affected by food dystrophy. Today we demonstrate that it can be done with omental cells, I mean with the mesenchymal cells coming from omental origin, which means that we don't need the corneal endothelium any longer. This is obviously something that will be developed in the next 10 years, and the next 20 years we shall have an organoid. Organoid is a structure in which we have a construct with epithelium, stroma and endothelium in one single cornea that can be implanted, not transplanted, in the patient, and moreover we can customize this cornea according to the power and the shape in order to have this cornea available with the optical power that is required for a given eye. So the future is brilliant. There's a lot of work to do, but I have shown today is that this is a reality, this can be accomplished and will be accomplished in the future.